Namaskar, Sat Shri Akal, Adab, hello, hi, Kim Cho. A very pleasant and warm evening, guys. How are you all? My name is Shivam Gupta. I welcome you all to the session. And welcome, guys. Good evening. How are you? Hi, Shri Kumar. Good evening. How are you? Good evening, guys. Good evening. Ki hal chal? All good? Okay, so today we are going to have a very nice session on engineering mechanics, and you will get a lot of questions, a lot of concepts, and a lot of masti in this session. Okay, so we are going to play with engineering mechanics today. Okay, so we will have very good questions, we will have some tricky questions, we will have some conceptual questions as well. So you can enjoy the session. So for this session there is only one thing you have to do. First of all, just like the session, then just share the session with all your friends, and after that we will start. Okay, and yesterday many of you have given the answer and it was absolutely correct. So I have the list of all the students who have given the correct answers. So without wasting any time, let's go with the session. And the students who don't know me, so let me tell you about myself, like uh, about the examination and about everything else. We will talk about it later. But first of all, guys, my name is Shivam Gupta. I have 4+ year of experience, GATE, SSCG, RRBG. I have cleared all the examinations, and my area of expertise for AG level is complete mechanical engineering. Okay, actually I was thinking about to give you the lectures on engineering mechanics, theory sections. So before that, I want to tell you that for the theory sections you have to wait for few days. After that I will give you the theory sections of engineering mechanics. Before that we will see the questions of engineering mechanics. Okay, hi guys, hello, good evening. Okay, and guys, if you have any problem, if you want to mail me any personal thing, then here is my mail ID, you can mail me. Okay, so let's go with the homework questions. And here we have the homework question. And yesterday I have asked that hydrostatic law states that the rate of increase of pressure in a vertical direction is equal to, so in a vertical direction it is equal to the specific weight of the fluid, right? Fluid specific weight. So option number B is absolutely correct. And another question was, all the experiment does the indicate that there can be laminar flow in a pipe if the Reynolds number is below. So for the Reynolds number below 2000 will be laminar flow, and for the Reynolds number above 4000 will be turbulent flow, and the Reynolds number between 2000 to 4000 will be transient flow. Okay, so this was the homework question. And first of all, Anurag have given the answer, then Dancing Gilbert, then Kingshuk, then Shubham, then Radhikant, and Satish, AB Learning, Sagar, then Kalpana, then Rahul, Rajiv, Kranti, and Gurpreet. So these were the students who have given the correct answer, and many congratulations, guys. And let's start today's session with one motivational thought, and it is the dream big. You have to do 3 steps for your dream, that dream big. If you are thinking about to earn gold, then you have to think about that diamond, right? Then set goals, you should have some goals. Okay, then after that take action, you have to take action for that. So these are the 3 steps for anything, any aim, any goal, you can take it. Okay, and one more thing, you have to be positive always, right? Okay, so with this positive attitude, let's go with the first question, and this is on your screen, that the polar section modulus of a solid circular shaft of diameter d about an axis through its center of gravity will be pi by 4 d cube, pi by 8 d cube, pi by 16 d cube, pi by 32 d cube, or pi by 64 d cube. You have to give the answer in this manner so that you can give the answer very quickly, you can give the answer very easily, and you can remember the answer for the longer period of time. So just give the answer. Is calculator allowed for Vizag? No. Okay. Good evening, Vishal. Sri Kumar says translation motion lecture. Sure, Sri Kumar. शुभम सर 8 बजे लेक्चर लाइव देख पाऊंगा क्योंकि अच्छा कोई बात नहीं शुभम एंजॉय ओके option number B, option number C. Okay, let's see what it is saying. It is saying like the polar section modulus. We have read that section modulus is denoted by Z, but if we talk about the polar section modulus, that is ZP. Okay, what is ZP? We know that I upon Y, that is moment of inertia upon Y, is known as Z. And if I talk about J upon Y, that is polar moment of inertia upon Y, will give you ZP. And for polar moment of inertia, you know that it is pi by 32 d to the power 4 divided by Y, that is d by 2. And when you solve it, you will get your answer, and the answer is pi by 16 d to the power 3. So the correct answer will be option number B, pi by 16 d to the power 3. Okay, let's go with the another question, and let's see who will be the first one to answer the another question. So another question is saying that the ratio of the moment of the circle and that of the square having the same area about their centroidal axis will be. Very good question. It is asking about the moment of inertia of circle to the moment of inertia of square. Right? Wow, what a question. I just gave you the hint. Just give me the answer. What will be the answer for this question? Actually, this is not the easy question. Okay, this is not an easy question. Not an easy question at all. But it is very good question, and it is very conceptual question. I will explain you each and everything about this. But first of all, you just try and let's see who will be the lucky one and who will be the smarter one to give this answer very quickly. Okay, give the answer, guys. Give the answer quickly. Okay, give the answer, guys. Come on, fast. You have to be fast. You have to be quick. Now see, trick in this question. Actually, there is a trick in this question. It has saying that square and circle is having same area about their centroidal axis. It means that it is saying that pi by 4 d square is equal to a square. Are you getting what I'm saying? Or just take it as a d, right? D square. No, don't take d. Just take the square of the side as a. Okay, just take it a. Then it will be great. A square, right? Then what will be the answer? So C and D are same. Yes, C and D are same. Okay. So what's the big deal in it? Okay, option number D or option number C? Okay, we have to find it. Okay, now let's see. We are going to find the solution. See, it is saying that it is having a same area, pi by 4 d square for the circle, right? And for the area of square, that is square area a square. Okay. Now, if we will get the answer for this, then we will have root of pi by 2 d equals to a. Right? We have taken this square and put here for the square root, and after that we will get that root pi divided by 2 into d equals to a. This will be the side of the square. Okay, now we know that I of circle is pi by 4 d square, pi by 64 d to the power 4, right? And I for the square is what? BD cube by 12. So it will be what? A to the power 4 divided by 12. Okay. Now what it is saying, I of circle upon I of a square. It is I of circle upon I of a square, and it will be pi by 4 64 d to the power 4 divided by a to the power 4 divided by 12. And if we will put the value of root pi upon 2 into d, here we will get the solution. Okay, so the answer will be let me write here. It will be pi by 64 d to the power 4 divided by root pi by 2 into d to the whole power 4 divided by 12. Okay, so d to the whole power 4, तो d4 से d4 काट दो, यहाँ पर ये क्या हो जाएगा पाई स्क्वायर और यहाँ पर क्या है पाई. So what we will get pi. Okay, and here it will be 2 2 are 4 4 2s are 8 2s are 16. Okay, so what we will get let me write it here. Okay, that is pi by 64 divided by pi square, and here we will have 2 2s are 4 2s are 8 2s are 16 into 12, right? Okay, now solve it. एक पाई से एक पाई गया, and here we will get 16. Very good. 16 into 12 divided by 64 into pi, right? Okay, now here 16 1 is 16. Do you know the table of 16? 16 1 is 16, 16 4s are 64, and 4 1s are 4, 4 3s are 12. So you will get 3 by pi as an answer. I told you this was not an easy answer. This was not an easy answer at all. And after that you get that 3 by pi. So the correct answer will be 3 by pi. And Sharmila, J.S. Srinivas, Harsh Vardhan, and TNV Kishore, and Shubham Gangwar, and okay. And these were the students who gave the correct answer. Shri Kumar, very good. Rahul, very good. Good, great. Good going, guys. Good going. अच्छा, वेरी गुड, बहुत बढ़िया. सरवन, वेरी गुड. चलो चलते हैं अगले क्वेश्चन पे. अगला क्वेश्चन आपकी स्क्रीन पर ये रहा. Now the question is saying that assertion is the preferred cross section area of the beam subjected to transverse loading is I section. Okay, and the reason is the section modulus of I section is low. Okay, what will be the correct answer for this question? See, for this question you should know the relation between the eyes of different sections. You should know the relation between the eye sections of different sections. Okay, you are giving the answer option number A. What will be the answer for this question? What will be the answer for this question? Guys, tell me. Fast, you have to be fast, okay? For the assertion, it is saying that the preferred cross-section area of the beam subjected to transverse loading is I section, and here reason is given that section modulus of I section is low. What will be the answer? Option number B, that both A and R are true, but R is not the correct explanation of A. Okay. Option C, Neeraj Kumar is saying option number C. Very good. Just be fast, guys. See, you have that level that you can give the answer very easily, right? You can give the answer very easily. So just give me the answer. Okay. Do you know we have many cross sections like I, T, rectangular, square, circular, that is sphere, and that is diamond. We have many cross section areas, and section modulus for different cross section area is different. So let's see. You will get the answer. Do you know what is section modulus denoted by? It is Z. And Z is maximum for what? Do you know that? Z is maximum for what? Okay. Can anybody tell? The section modulus for the maximum section modulus can be achieved in one cross section which is looking very thin, but it is very awesome, and the section modulus for I section is maximum. Section modulus for I section is maximum. After that, section modulus of T section is coming, right? Okay. And after that, what? After that, the section modulus of rectangular section came, and after that, the section modulus of square section came. You know that? Yes, for I section. So here it is written like section modulus of I section is low. And I don't think that section modulus of I section is low. It is the maximum among all, right? So section modulus for I section is not low, it is maximum among all. So reason will not be the correct answer, right? So if reason is false, then absolutely option number A, assertion A is correct. And for that, you will have option number C, that is A is true and R is false. So option C will be the correct answer. Did you get the concept? Did you get the concept? Yes, very good. Very good, Pratik. Good going. Yes. So आंसर क्या हो जाएगा इसका? ऑप्शन नंबर सी. ऑप्शन नंबर सी पर ताला लगाइएगा guys. Okay. Now coming to the next question. Next question on your screen is, you have to be quick, you have to be clever from mind. Okay. समझ जा. I have many googlies and I can bolt you, right? I can take your wicket. Okay. 13-14 में है क्या? तब तक रिवीजन हो जाएगा सब सब्जेक्ट का? बिल्कुल शुभम, और क्या, जरूर. इसमें पूछने वाली कौन सी बात है? कितने दिनों से तो रिवीजन चल रहा है, राइट? ओके, बताओ. विच क्रॉस सेक्शन ऑफ द कैंटिलीवर बीम विच इज लोडेड विथ यूडीएल कैन गिव द इकोनॉमिकल डिजाइन? ओए होए होए होए. Now again, this is a very good question. For an economical design, which kind of cross section you will choose? Square, circular, I section or rectangular section? For an economical design. Do you know what is economical design? Sure Vishal, revision strategy भी बता दूंगा. No problem. Okay. So what will be the answer for this question? What will be the answer for this question? Yes, great Pratik, great TNV, great Shivendra, good. Dheeraj, बहुत बढ़िया. Nice. So the correct answer for this question will be I section. Just I told you that the section modulus for I section will be maximum among all the cross sections we have, like T, rectangular or square or rhombus or circular. Okay, so among all I section will have the maximum section modulus, and if I have the I section as maximum section modulus, then it will be most economical design. Okay, so option number C will be the correct answer. Hi Radhakanta. Option number, next question is saying that in case of a circular section, the section modulus is given by. Very nice question, and it is very easy question. You have to be quick for this. I section is used below bridge. Boina, if you have seen your grandparents' house, just like my grandparents' house was made only on I section beams, you know. I can see that is the I section beam. We call it girder, right? Okay, what will be the answer for this question? Option number B, option number C, option number D. Okay, there are many versatile answers. So let's see what will be the answer. We know it is asking about the Z, that is section modulus. Okay, and what is Z? That is I upon Y. Okay, and I for the circular cross section is pi by 64 d to the power 4 divided by y, that is d by 2. When you solve it, you will get 32. When you cross it, you will get d cube. So the answer will be pi by 32. Okay, so the answer will be pi by 32 d cube. Okay. Clear है? Clear है? So answer will be option number C. Option number C will be the correct answer. Now coming to the next question. Next question is saying that the strength of the beam mainly depends on. Now see, this is very good question. Actually, we know or we understand that the strength of the beam depends on moment of inertia, right? But no, it is not the correct answer. Moment of inertia. Moment of inertia is not the correct answer. So don't choose moment of inertia. Okay, you have to choose what? For that, you should know the bending equation of the beam, and bending equation of the beam is saying that sigma upon what? Y equals to m upon what? I equals to E by R. And if we choose these two relations, then we can say that the bending stress, that is the strength of the beam, depends upon what? My upon I. And if I take this y in denominator of the y, we will get m upon zp, right? So the bending stress or the strength of the beam mainly depends on what? Mainly depends on the section modulus of the beam. So answer will be option number C, right? Okay, that's why you have seen that the railway track having a cross section of this. You know that? It is similar to the I section, right? The railway track is looking like this only. The cross section of the railway track. Have you noticed it? Right? Okay. So answer is option number C. Now coming to the next question. Next question is saying that which is the correct option for the polar moment of inertia of a solid shaft. So what is the polar moment of inertia for a solid shaft? Do you know? What is polar moment of inertia? Okay, this polar moment of inertia is also known as second moment of inertia, right? Second moment of area. Okay, what will be the answer? Now see, we know that polar moment of inertia is known as what? Is denoted by J. And J can be written as Ixx plus Iyy. Since we have the solid shaft, so Ixx for solid shaft will be pi by 64 d to the power 4 plus Iyy will be same as pi by 64 d to the power 4, and when we add them we will get J equals to pi by 32 d to the power 4, right? Okay, and can you see the options here? No. Yes. So that is the point. You should notice that none of the above is correct. None of the given options. Yes, that is the level of concepts you have in your mind, right? Okay, 32 should be there. Yes, 32 and d to the power 4 is also a main thing. Here it is written pi by 32 d square. No, it is not a correct answer. Pi by 32 d to the power 4 should be there, right? This 4. Okay. Now coming to the next question. Next question is saying that radius of the curvature of a stressed beam and modulus of elasticity are directly proportional, are inversely proportional, are curvilinearly related, or have unpredictable relationship. See, this is the question which is basically depends on the formula, right? You can give the answer only and only based on the formula. So if you know the formula, it is good. If you don't know the formula, I am writing the formula here. And for formula, you know that formula is of bending equation formula. And we know that bending equation formula is sigma upon y equals to m upon I equals to E by R. And the question is asking about the radius of curvature R and the modulus of elasticity E. Question is asking about the relations of E and R. So we can make the relation as this and from this. So from the first one we can get that R multiplied by m upon I will be equals to E, and R multiplied by sigma upon y will be equals to E. Now it is asking the radius of curvature of the stress beam and the modulus of elasticity are directly proportional, inversely proportional, or are curvilinearly related, or have unpredictable relationship. See, the students who are giving the answer as directly proportional and inversely proportional, let me tell you that you both are wrong. You are ghangor wrong. Okay, this is not a correct answer. It is not directly proportional. It is neither inversely proportional. Why? See, we have m upon I, we have sigma upon y, right? We have I as the moment of inertia, we have y, we have the bending stress, and we have the bending moment mb value. So we have the four things in our equation which can decide the relationship between E and R. You know that, right? Because m upon I and sigma upon y all are variables. They are not constant properties. They are variables, and if they are variables, how can you decide that R will be directly proportional or inversely proportional? You don't have any right to decide until and unless we can say that m upon I or sigma upon y is constant. They are variable, right? So how can you say that it will be directly or inversely? If the question is saying that keeping all the things same, right? If the question is saying keeping all the things same, all the parameters same, right? Parameters same. If the question is saying keeping all the parameters same, then you can say are directly proportional. But if R is not if parameters are not proportional or not same, then you cannot comment anything. It does not depend on anything. Yes, you can see it does not depend on anything. Actually, it depends on the bending stress and the bending stress, I'm saying normal stress and normal strain. Okay, but you have to think that it will not be directly nor inversely proportional. Okay, so answer will be option number D. Option number D will be the correct answer. क्लियर है सबको? बढ़िया, जबरदस्त. चलो आगे बढ़ते हैं. Okay, now the question is saying bending stress on a neutral axis of a cross sectional beam will be maximum, minimum, zero or infinity. This is the easiest question of the engineering mechanics it can be. So guys, this is the engineering mechanics related to bending or the study of the deformable bodies, right? Engineering mechanics based on the study of deformable bodies. I will give you the questions of the engineering mechanics based on the basic physics concepts. Okay, so you will get the questions of the acceleration, you will get the concepts of gravitation, you will get the concepts of momentum and everything. So don't worry about that, just give the answer. Option number C, yes, absolutely correct. Absolutely correct. Option number C. See, the bending equation can be give the diagram of this kind, and it is giving the bending diagram of cross sectional beam, right? And here we have a 0 what bending stress, sigma b equals to 0 here. This is a diagram of the bending stress. Okay, 0. Very good. Now coming to the next question. Next question is saying that the force keeping the planet in a regular orbit is. Now coming to the basic physics level question of engineering mechanics. Basic physics level question. Basic physics level question. Okay, let's see how many of you know the basic physics. Okay, what will be the answer for that? That is gravitational force. Okay, do you know what is the formula of gravitational force? What is the formula of gravitational force? Anybody? What is the formula of gravitational force? We know that there is a gravitational force between two bodies which are attracting themselves to each other, right? So what will be the answer for this? That is, you know that is gmm by r square, right? Right? That is gmm by r square. Remember? Yes, that is option number C, gravitational force. Okay. Now coming to the next question. Next question is saying that the process of finding out the resultant of a given number of a forces is known as. Wow, what a question. You must have heard about the composition, resolution, decomposition or superposition. The process of finding out the resultant of a given number of forces is known as. See, it is asking about the resultant of the forces. Okay, it is asking about resultant of the sun, keep them in orbit. Yes, Vishal, very good. Now give me the answer. The process of finding out the resultant of the given number of forces is known as resolution. Option number A, composition. Option number B, resolution. Okay, it should be centrifugal force. It didn't give it in the option. Okay, no problem. Resolution, revolution. Huh? Do you know what is composition of force? You know what is composition of force? Huh? You should know what is the composition of force. Okay. चाइना मेड आर्टिफिशियल सन. अरे भाई साहब, अरे बाबा, ओ माय गॉड, बहुत सारी चीजें आपने बता दिया. हाँ, चलो. Resolution. Okay. It's not resolution. Okay, it's not a resolution. Resolution is not a correct answer. Answer is composition. Actually, the process of finding the resultant of a given number of forces is known as net force. Actually, it is known as the net force, and it is not a actually resolution of the forces is kind of, you can say it is a process, but the answer is composition, right? On resolving the forces, we know that it will give you the resultant. Anurag? Yes, प्रकाश, आपके बोलने के पहले ही हम समझ गए. ठीक है. ओके. ओके. सी, तो अगर आप लोग बात करते हो तो यहां पर आंसर क्या होगा? कॉम्पोजिशन एंड रेजोल्यूशन. 150 बिलियन पावर. ओ माय गॉड शुभम, अब तो हम लोग उसी में ही चले गए हैं. राइट. ओके, इट्स ओके. ओके, सो गिव मी द आंसर ना. कॉम्पोजिशन, रेजोल्यूशन. Composition or resolution? You know that composition of the forces. What is composition of the forces? Composition of forces, right? That is the answer. Ravi, see, we have some basic difference between the resolution and composition of the forces. It is saying that finding the resultant of the number of forces means if you have the force 1 this, if you have the force this, if you have the force this, right, then the resultant of this, that is the net force, it is Fn. This net force is known as the composition of the forces. It is the sum of all the forces. Okay, but resolution is not the sum of all the forces. Are you getting what I'm saying? Resolution is not the sum of all the forces. Mixture of horizontal and vertical forces, that is the composition of the forces. Yes, and it is saying that is the resultant of the given number of forces. Given number of forces means we have force 1, we have force 2, we have force 3, and you have to find the resultant, and the resultant of all the forces, that is known as net force, and net force is known as the composition of force. Okay, so answer will be A. Ravi is saying that resolution is resultant. Yes, resolution is the resultant. So here you have written right now that the process of finding the resultant or resolution is what? It is composition. If you can read the question like the process of finding out the resolution of a given number of forces, then what is that? So it is the synonym of the resolution. Now so we have to find the resultant, and that is the composition, brother. Okay. Right. Okay. Now coming to the next question. Next question is saying that the condition for equilibrium state always correct. Fx equals to 0, Fy equals to 0, Fz equals to 0, or Fx equals to Fy equals to Fz equals to 0. Okay. What will be the answer for this question? Give me the answer fast. Come on, fast. Come on guys, you have to be fast. See, If we talk about the equilibrium state, in equilibrium state, all the forces become zero, or the net force becomes zero. Then the Fx equals to Fy equals to Fz will be equals to a big zero. Option number D will be the correct answer. And the next question is saying that to every action, there is always an equal and opposite reaction. This statement is known as Newton's second law, Newton's third law, Newton's first law, or law of momentum. This is the very basic question, right? This is the very basic question. Okay, and the answer for this question will be option number A, Newton's second law of motion. Yes, we have the correct answer, Newton's second law, right? Okay, great. Newton's second law of motion is the correct answer. To every action there is equal and opposite reaction, है ना? राइट यस. अच्छा, थर्ड लॉ होता है क्या? मुझे तो न्यूटन सेकंड लॉ पता था यार. तो अच्छा, तो न्यूटन सेकंड लॉ क्या होता है? व्हाट इज न्यूटन सेकंड लॉ? व्हाट इज न्यूटन सेकंड लॉ? Yes, you guys are correct. That is Newton's third law is saying that every action, for every action there is equal and opposite reaction. Now tell me, what is Newton's second law? Do you know what is Newton's second law? न्यूटन का तीसरा कानून. Oh my god. Okay, now tell me, what is Newton's second law? Just give me the answer. What is Newton's second law? See, if I talk about a formula, then you know that after the Newton's second law, we have written like F equals to ma. And Newton's second law किसके बारे में बात करता है? Momentum equation. Very nice, great, very good. Now coming to the next question. Next question is saying that if we place some coins over a paper strip and pull it with a jerk, then coins don't fall off because of. कह रहा है we have a paper, right? We have a paper, and if we have a coin in it and just pull out the paper with the jerk. Do you know what is jerk? That is a jhatka, that is an impact. Do you know what is the relation of jerk, acceleration, and velocity and displacement? Okay, F equal to ma. Very good. The rate of change of momentum is proportional to applied force. Very nice, Anurag. Very nice. Second law is momentum. Okay, very good. जड़ता का नियम. Rahul, are you from Hindi medium? Okay, option number C. Great. Inertia. Yes, inertia. Do you know what is jerk? Okay, do you know what is displacement? It is S, right? And if we write change in displacement with respect to time, that is ds upon dt, do you know what we get? We get velocity v, right? Velocity v. And when we write dv upon dt, that is change in velocity with respect to time, we get what? We get acceleration a. You know that? Yes. And when we write that change in acceleration with respect to time, then what we get? We get jerk. You know that? So this is the jerk. That is dA upon dt. The rate of change of acceleration upon time is known as jerk. And this is the jerk. And what is the law of inertia? Do you know what is the law of inertia? Inertia of motion, inertia of rest. Right? Do you know that? Yes. The inertia of motion is saying that if any body is in motion, then it tends to be in motion. If any body is in rest, it tends to be in rest. And do you know what is the inertia of sleeping? If anybody is sleeping, he always want to sleep, right? He tend to be in sleeping. Do you know that the inertia of sleeping is also there? It is invented by mechanical engineers. Okay, चलते हैं अगले क्वेश्चन पे. Next question is saying that if a body of mass 10 kg is moving with a velocity of 15 meter per second, okay, and force required to stop it is 5 seconds, should be 10 Newton, 15 Newton, 30 Newton, or 50 Newton. Do you know what is the answer for this question? See, this is a numerical question. It is very easy question. I can answer this question on fingertips. Without touching my pen, I can answer this question. Can anyone say that? Can anyone give the answer? Let's see who is the lucky one and who is the smarter one to give this answer. Okay. Every school example. Bus traveling, sudden brake. Yes, Rahul. Very good. 30. Ravi, very good. TNV, very good. Yes. See, it is saying that the force required will be what? Force required will be the change in momentum per unit time, right? Change in momentum per unit time. And we know that the change in momentum will be what? Mass into v final velocity minus v initial velocity divided by time. And mass is given as what? 10 kg, right? Divided by v final. Actually we want to stop it. Here it is written that force required to stop it, है ना? So v final will be what? V final will be 0 and v initial will be what? V initial will be 15 meter per second. Okay, so it will be 0 minus 15 divided by what? Divided by 5 seconds. So answer will be 5 2s are 10, 10 or 15 2s are 30. Answer will be C. Option number C will be the correct answer, right? Okay. MV by T. Very good. Very good. बहुत बढ़िया. Coming to the next question. Next question is saying that rate of falling object in vacuum is. Vacuum में rate of falling object क्या होता है मेरे दोस्त? बताओ. Rate of falling object in vacuum will be depend on mass, depend on weight, independent of the mass or independent of the weight. In vacuum, see, we know that in a vacuum there is nothing, right? There is nothing in vacuum. And if there is nothing in vacuum, then if you will drop a piece of paper or if you will drop a Bahubali, it is पेपर. दोनों को अगर नीचे की तरफ ड्रॉप किया, ऐसे छोड़ दिया, तो who will come fast? Who will come fast? Nobody. They will come at the same time. That is the phenomena of the falling in the vacuum, right? So acceleration due to gravity for Bahubali will be G and acceleration due to gravity for paper will also be G. That will be same. That's why they will come at the same time. It will be independent of the mass. Either it is piece of paper or either it will be, he will be Bahubali. It will come at same time. Right? Okay. Now coming to the next question. Next question is saying that when two objects are in contact, they exert force in opposite direction, same direction, both A and B या फिर perpendicular direction. Now give me the answer for this question. This is the conceptual question, you know. When two objects are in contact, when you make two objects are in contact, then they exert force in opposite direction, same direction, both A and B or perpendicular direction. That is the question. Example of the space astronauts, yes. आपसे साइंस का भी लेंगे एग्जाम के बाद. अरे जरूर मेरे दोस्त, जरूर. Okay, you are in space. Nice. Option number A. Option number A. Is it correct? Option number A. क्या सभी को कॉन्सेप्ट पता है ऑप्शन नंबर ए क्यों हुआ है? किसी को अगर नहीं पता हो तो मुझसे पूछ सकता है, मैं अभी बता दूंगा, मुझे कोई तकलीफ नहीं है मेरे दोस्त. मैं अभी बता दूंगा, मुझे कोई तकलीफ नहीं है. बताओ अभी क्लियर है सभी के लिए या फिर कोई डाउट है? ऑप्शन नंबर ए क्यों हुआ है? कोई भी मेरा दोस्त बताना चाहेगा? ऑप्शन नंबर ए ही क्यों? वाई ओनली ऑप्शन नंबर ए? वाई ओनली ऑप्शन नंबर ए? Okay, Newton's law. Okay, now see, I have one practical example of this question. If we have two friends like Ram or Shyam, okay, if we have two friends like Ram or Shyam, right, and if they are at a very long distance, then they tend to be closer, they tend to be at the same place, okay, and when they are in the same place, they tend to be the separate from others. Okay, this is the phenomena of what? This is the phenomena of any bodies, any two object, right? कोई भी ऑब्जेक्ट ले लो, अगर वो ऑब्जेक्ट दूर हैं, फॉर एग्जाम्पल वी हैव ए एंड बी एंड इफ दे आर एट अ डिस्टेंस ऑफ डी, then A and B tend to be at the same place. A and B will tend to attract each other, and when you make A and B at the same place, or when you make A and B at the same surface or at the same page, then A and B will tend to apart from each other. It is just like शादी का लड्डू, जो नहीं खाता वो चाहता है मुझे खाना है, मुझे खाना है, मुझे खाना है, और जो खा लेता वो कहता है बस अब मुझे नहीं खाना, मुझे नहीं खाना, मुझे नहीं खाना, I don't want it, I don't want it at all. You just go at another room, I will go at another room. Okay, so that is the concept behind this. So answer is option number A, opposite direction is absolutely correct. Now coming to the next question, and next question is saying that which of the following is a scalar quantity. Let's see which is a scalar quantity. It should be C. Okay. Newton had one crush. Okay, what will be the answer for this question? That what is a scalar quantity? You know that what is a scalar and what is vector quantity. There is no any doubt in it that you don't know the answer. What is the scalar quantity? Distance, displacement, velocity or acceleration. What will be the answer for this? Option number A, absolutely, absolutely. C, distance is a scalar quantity, but displacement is a vector quantity. It has the direction as well as the dimension, right? And distance is only and only a dimension. So distance is a scalar quantity. You know that? Right? Okay, okay. Do you know what is the stress? Stress is which quantity? Stress is which quantity? Do you know what is the dimensional formula or what is the name of that quantity in which stress comes? Do you know what is the stress? We know that it is not a scalar quantity, it is not a vector quantity. You know? You have a doubt? Batao. If objects are magnet, I didn't get what do you mean. Tensor quantity, very good, tensor quantity. Okay, you are asking the question if objects are magnet then what will happen, है ना? If magnets are there, see magnet का भी phenomena बहुत अलग है मेरे दोस्त, magnet का भी phenomena बहुत अलग है. Magnet में क्या होता है, नॉर्थ और साउथ होते हैं, नॉर्थ एंड साउथ, ओके है ना? अब ये आप लोग दो मैग्नेट्स लेकर के आ जाओ, दो मैग्नेट्स लेकर के आ जाओ, राइट? अब जब आप लोग मैग्नेट्स लेकर के आते हो तो पता आप क्या करते हो, आप यहां पर रखते हो साउथ और यहां पर रखते हो नॉर्थ, यू नो दैट? तब जाकर के ये अटैच हो पाते हैं. क्यों? क्योंकि ये देखो यहां पर मैग्नेट है, मैग्नेट किस साइड जाने की कोशिश कर रहा है, इस साइड जाने की कोशिश कर रहा है. सो ये वाला जो मैग्नेट है, दिस मैग्नेट, मैग्नेट 2 विल टेंड टू गो at north direction, and this type of the magnet, that magnet 1 will tend to go at south direction. Actually you have made the cross section and crossed dimension of that magnet, that's why they attracted to each other. But if you make the same pole, then it will not attract to each other, you know that? Okay, yes, yes, exactly. Now the next question is saying that which of the following is a vector quantity? Acceleration, velocity, displacement, or all of the above? Guys, you have to be fast. You have to give the answer quickly because I have another session at 8 p.m. on Gradeup channel, and you most welcome. You all are welcome on that channel, and I will teach thermodynamics, thermal engineering there. Okay, so if you want to revise the questions of thermal engineering, you can come at Gradeup channel also. Okay. Now give the answer. Which will be the vector quantity? Acceleration, velocity, displacement. All of the above. Wow, you are smart. Answer will be option number D, that all of the above is a vector quantity. Vector quantity is a quantity which is having what? Direction as well as what? As well as dimension. So you have to be what? You have to be vector quantity. You should have dimension, your strength, and a direction that you have to take this examination as an aim, right? That will be the direction, direction. Then you have to be a vector quantity. Now the next question is, the entropy of an isolated system will be. Entropy of an isolated system will be never decreases, always increase for an irreversible process, remains constant for reversible process, yeah, all of the above. What will be the answer for this question? Pratik, give me the answer fast. Come on, fast guys. Direction and magnitude. Very good, Rahul. Give me the answer. Entropy of an isolated system. Isolated system is a system in which there is no heat transfer and there is no mass transfer. That is known as isolated system. And practically isolated system cannot be possible. Even Brahma ji will come and say, I will make isolated system. हम बोलेंगे ना हो पाएगा, आपसे भी ना हो पाएगा. Okay. So entropy of an isolated system will be option number D. Yes, absolutely correct. It can never increase. It can be zero, it can be positive, but it cannot be negative. Entropy of reversible process can remains constant. It can be zero. Change in entropy can be zero, right? But it cannot decrease. It will always increase for what? For irreversible process. So option number D will be the correct answer for this question. Are you getting? Yes. That is the point. And here we have another homework question that is saying that consider the bending equation given below and what is R here. This is a very easy question and I want you all to give the answer in the comment section. Okay, then you have to give the answer in comment section. And guys, if you like the session, then it is your responsibility or it is your duty to give the review, to comment about the session in comment section, right? About the session in comment section. Okay, comment section पे आप लोगों को comment जरूर करना है. So एक बार comment जरूर करना है. And राहुल, आप लोगों को ये आंसर देना है किसमें? ये आंसर देना है आप लोगों को comment section में, और comment section में ही आंसर देना. And guys, we do not have that much of time, so I have to take a sign off and come to Gradeup JEE channel for thermal engineering. Okay, I'm gonna discuss thermal engineering questions on Gradeup JEE channel, so you all are most welcome. Okay, and how was the session? Did you enjoy? बोर तो नहीं हुआ कोई? मजा आया ना? कोई सो तो नहीं गया? Right? Okay, just enjoy the session. Just be cool, be normal, be excited, and always be positive. That is your strength, guys. You are the mechanical engineers. You represent the world. No, seriously, you represent the world. I will tell you, right? Okay. Okay. So thank you so much. And increases anyway irrespective of the process. It will be reversible or irreversible. No, for the reversible process it can be constant. It can be constant, but for irreversible process it is always increasing because of the entropy generation term. Okay. Yes. Okay. चलो फिर मिलते हैं अपन नेक्स्ट सेशन में. तब तक के लिए बाय बाय. गुड नाइट गाइस. गुड नाइट. बाय बाय.